Hello and a warm welcome to our Tech Talk webinar about COMOS data and document management, otherwise referred to as DDMS, as Dom already suggested. You'll hear that acronym, I'm sure, quite often in this presentation. My name is Russell Crane, and I'll guide you through today's session, in which you'll hear about intelligent handling of plant-related technical data and documents. So, our agenda for today, Tracy is going to kick us off with a session on the industry challenges and drawing on her 20+ years of experience in the pharmaceutical industry. Tracy will then present to you why the first D in DDMS is so important when considering the plant or asset lifecycle. I'll then present to you the Siemens solution and show you some features of COMOS DDMS, including the benefits as we see them. We'll finish off with an opportunity for you to ask some questions, and don't forget to use the chat, and we'll endeavour to answer those questions as we go, and also at the end. So with that, I'm going to hand over to Tracy, who will take you through the first part of our presentation today, which is on the industry challenge.
I think you're muted, Tracy.
Yeah, thank you, Russell, and a warm welcome from me as well. Sorry about this. Right. Data and documentation management is a challenge across all industries, particularly in the regulated pharmaceutical sector, where maintaining GXP compliance and data integrity is a key focus point. Between 2014 and 2018, around 50% of the global drug 483s and 79% of the global drug warning letters issued by the FDA involved data integrity violations. One of the most significant challenges in an operational facility is the management of change control, and the drivers to minimize downtime and ensure constant market supply can make it a struggle to maintain a compliant documentation set. Today, we're going to talk about a solution that helps to keep track of your asset documentation. Engineering is performed in accordance with good engineering practice. Manufacturing is performed in accordance with good manufacturing practice, but both need to be supported with good documentation practice, which includes proof of specifications, proof of evidence, proof of inspection, and proof of documentation. So in order to maintain compliance, any kind of operational or engineering changes have to be performed in a controlled way. Let's have a quick look at this concept and how it influences daily work in regulated industry. The change initiation comes first. This is the clear declaration that a change will take place. After the formal change request creation, the engineering work will take place. When all the engineering has been completed, the change will be released. And the output of this process includes all the documentation, engineering documentation, quality-related documents, certificates, and data such as lists, design data, or any kind of relevant technical data, for example, measuring ranges for calibration of instruments. This will lead to the formal change request closure. And for an EPC or an internal engineering department, it's almost the end of the story. Just submit the lifecycle relevant information to the operating part of the company and wait until the next change request occurs. However, there will be additional changes with a lot of iterations, annually several hundreds per site, and these all need to have a complete, up-to-date, as-built set of documentation to start from. Otherwise, it becomes a nightmare to gather together the relevant and correct information. Optimizing this crucial handover to operations is what we focus on, helping to bring together the project and the delivery stages. This slide is going to show a more detailed analysis of the typical software tool landscape, and I'm sure that you'll find one or more of these software tools being used in your company. We have quality systems, a lot of different tools in the engineering part, well-known ERP systems, and tools for things like e-calibration. Let's skip the details and focus again on the handover to operations step. As you remember, relevant information consists of both documents and data, but we see that ordinary document management systems are only capable of managing documents, as the name suggests. If we ignore relevant data and only transfer documents, we generate problems straight away, most notably compliance with the principles of data integrity and Alcoa Plus. Now, let us take a look at a typical situation in industry today with a standard document-orientated workflow-based DMS. I think you'd agree that most of the decision makers in industry think that it works like this, and that after buying and installing a document management system, they've gone digital with a central DMS providing a single source of truth. However, as we know, reality is somewhat more complex, with relevant information existing in multiple medias and changing continuously. So now, ask yourself what is really in the centre: a human, and not the document management system. Each team member handles many different data sources with lots of information stored in multiple media. So you wind up with documents from many island solutions that are stored again in other island solutions. And what happens later on? Well, during the project, many different documents come in from many different members. And now it becomes much more difficult with a lot of documents that have to be approved. And during this time, many changes and change requests, both internal and external, will appear. So, when we're talking about documentation, we generally have small folders in mind. It might even be a cabinet full. But pharma projects are getting bigger and bigger with increased complexity, operating at a fast pace and increasing regulatory pressures in terms of documentation requirements, with many of them undergoing changes often, even in the commissioning phase. So small projects, not really. The reality is somewhat different. We're talking about loads of documents. To give us all an idea, here are some examples of pharma projects. We created this illustration based on a customer's idea and found that ship containers are appropriate units of measurement. Boehringer, the LSCC project in Vienna, which is a volume of 800 million euros, will create documents that require around 3,500 paper folders, and that translates to 3 shipping containers. CSL Behring in Switzerland spent 900 million euros on a blood plasma manufacturing plant, which will require 4,000 folders of documentation, or 4 shipping containers. And Roche spent an unbelievable 2.7 billion euros and created roughly 11,000 folders, or 9 containers. That's a lot of paper-based documentation. So in 2020, why not use PDFs? I think that this is a really interesting illustration of the amount of documentation that can be generated and stored for a pharmaceutical project. As I've shown you, most companies are using a standard DMS to handle this mass of documents in their projects. COMOS, as a data and document management system, has a unique capability to handle data, and having a system connected to all other systems that can act as a data hub can be a game changer. As mentioned before, we're talking about facility and asset documentation, which means that asset data is at the center of the workflow. Every asset is an object in COMOS, and every document gets its information from the object itself. That is the basis of a real single source of truth and ensures consistency. All changes are pushed through, and it's possible to have a full overview at any time. So let's look at how to get to having full knowledge of a facility, or the way to knowledge. At the beginning, there are just characters, letters, or words. By merging these characters or words in a smart way, you get a statement, which is the data. By adding a meaning to these statements, you get information. And by combining information with experiences, you come to knowledge. So what does that mean in a project or operating environment? It starts with an idea and drawings and schematics. Then there are engineering specification data and production data. And knowing the full meaning of these data sets combined with the schematics gives the full information of the project or the production facility. This information, combined with the experiences of our customers, brings them to a level of having an overview and knowledge about the project or the production facility. We will focus on the data section, which is a fundamental step to having information and achieving knowledge. So, now what kind of data are we talking about? Remembering that the environment is plant engineering or asset lifecycle management. The most important one is the asset data, such as a functional location, which is the unit location structure for equipment and devices and their elements, as well as their specification data. And then there is the assets documents with metadata, which are important additions and external information. And then to get to information and then knowledge, you need the operations data, which are values of attributes that change throughout the project or the facility lifecycle, and the user data, which encompasses the team members and their roles and access rights for each area of the project or facility. All of this data has to be managed and maintained in an engineering project or production facility, and it is all required. So if one element is missing, there is a problem and there'll be compliance issues. That means we need a system which is not only storing the document files, we need a system that's able to maintain data consistency. So to remain consistent, the system must push through all the changes automatically. And to complete the circle, we need a system that interconnects the documents to other data and other documents. We need a system which is able to manage the master data, a system that gives a single source of truth. And from my point of view, COMOS DDMS is the only system that fulfills all those requirements. So now what happens when we decide to take the COMOS DDMS and implement it in a real situation? Here we see a typical roadmap by starting from paper to delivering full digital capability. Starting with an asset data structure, information such as the site, the building, the floor, and the equipment group are created. Various documents are then mapped into this structure. Data is then extracted from these documents. And at the end of these 3 steps, you'll have created a basic DDMS. But you can then expand on this. So if you add into this intelligence engineering, such as P&IDs, electrical, instrument and control data, data sheets, etc., you can establish the DDMS as a data hub, where you can always also store ERP, process control and calibration data. You can then add in 3D integration data, data from sources such as MicroStation, Autodesk or SolidWorks, as well as data analytics. And that gives you a COMOS engineering and lifecycle management system, which is able to support you to manage and change the asset throughout its life. So here we see an overview of document and data challenges in our projects and how COMOS DDMS has functionality which can help support you, such as document management, document content handling, document release, document search, and document correction. And Russell is now going to show you how some of these features work in more detail. Over to you, Russell. I think you're still muted.
Okay. Just need to remove the mute. I think that's the key to that one. Thanks, Tracy. Yeah, nice presentation. As Tracy's described, a DDMS can make a massive difference when managing the life cycle of a plant. So what is the Siemens DDMS solution? Well, at the heart, we have the kernel, if you like, which is COMOS. COMOS, for those who are familiar, is obviously a much larger tool, but in the context of DDMS is responsible for the environment, for the structure, and ultimately the database where the data and documents will be stored. We next have the project quality module. Now, this module is responsible for things like document revision control, workflow, document release, and the change impact process. Third component part is the web-enabled interface, which gives us a simple, easy-to-use, web-enabled user interface and brings a different aspect to the DDMS, probably different than other document management systems we've seen. So, displayed on the screen, we have 12 key functionalities of the Siemens solution. But today we're going to concentrate on those aspects which relate to data, and these will be highlighted in a second. So the areas we're going to be focusing on for this presentation are functional location, content-based text searching, the web object search function, dashboarding, change impact support, and then the two content converters, one being PDF and the other being AutoCAD. So we'll start with our first area of interest, which is the functional location, or the first set of functionalities. We'll look at so this is functional location, or FLOC, as the acronym suggests, which is a combination of the unit, its location structure, the equipment devices, their elements, and of course the data that sits behind them. So for each of the functionalities that I'm going to go through today, I'll give you a brief overview of the benefits of those functionalities, and also a little bit of a view into the COMOS world to see what it physically looks like in the DDMS tool. So we'll start with the functional location and some benefits. So we have a direct association from the assets to the document. So that's connections, reference links, etc., that bring those two things together. We have a visible tagging structure, which you will see in the subsequent videos, and you'll see how that looks and feels. Again, a visible location structure, which I think you'll see again in the video as to how the information is stored in this structure, and of course the documents that are visible within that structure as well. We also have the possibility of linking those documents to other assets or objects or other documents, and the facility will also give us a really good search engine and fast search mechanism. So I'm going to now show you a short video, which is an insight into the COMOS DDMS environment, and what we're going to be looking at is how you would start to build up that functional location structure within the COMOS environment. So first of all, you can see that this, for those who've seen COMOS before, this is the COMOS DDMS client, and what we're doing here is first of all creating what they call a unit, or in real life it would be something like an area of plant within your site. We're then going to create, or the video is showing you that we're going to create a sub area or a subunit, which would typically be a floor or another area of the plant, for which you can establish different properties, ambient temperature, for example, pressure, and other variants if they're relevant. What we're then going to do is create some equipment in that area. So in our example, we're going to create a tank with an agitator, and then show you how easy it is to create a second tank with exactly the same capabilities with an agitator. We're then looking to connect those pieces of equipment to its control, if you like, or its unit, its structure, location, and by connecting this to in this case, the control room, we can then see that the cabinet that those equipments will be controlled from, and ultimately the control station which will be responsible, or the automation station which will be responsible. The very brief view of the folder structure was also evident there when looking at the video. Okay, so that's just a very brief insight into how that functional location structure would be created for a couple of items, but this would be true of all of your plant and all of your sites. So you can see the power of having that functional structure within a system such as the DDMS. Okay, so Next, we're going to come on to is the content-based full text search function. And this is one of the main differences between a classic DMS and a COMOS DDMS. So again, I'll go through some of the benefits of the full text search, and then we'll show you a brief video of that function in operation within DDMS. So first, starting with the benefits and looking at the first of those, which is content of the documents can be retrieved. Now, being able to read the content of the document and search for wording, tags or numbers saves a lot of time and stress. And this is available from the first check-in of the document. COMOS scans the whole document, creates separate index tables. You've no need to prepare anything. It just works. We also have the ability to continuously update the content for the full text search. And again, no preparation needed in the metadata. It will just bring it in through the check-in profile. We have a fast hit list available, which we'll show you in the video, and possibility to navigate from this hit list, which again we will show you this in the video. So we'll take you into the world of full text searching. So the first thing we have to do is to switch to the content-based search inside COMOS, and then by typing in the search criteria, we display a list of relevant documents for that particular asset. We're then able to go into a document preview, which will show you in a viewer the actual equipment that you're searching for. In this case, tank B001, and within that viewer, you're able to perform zoom and pan and move around that in this case the P&ID, so that you can actually see that equipment on the actual drawing within the system. Also, as you can see there in the list, you see other data available for that equipment. So that there are various data sheets and other information that can be stored against that particular asset. And this is the power of having that data assembled with all of the documentation within the system. Okay, so next we're going to come on to the web DDMS object search. So this is the third component that I mentioned at the start, which is the web-enabled functionality that we've provided within DDMS. And this search function makes it possible to find objects using a web-enabled engine, and gives you some extra benefits that are probably not possible in other DMS. The interface is easy to use and is pretty fast, and hopefully we can see that in the demonstration. So I'll first start with the benefits and what we feel are the advantages of having this web-based search engine. So you have an ability to search for the asset or the object inside the flock structure, which, as we've just been through, is the functional location structure. So you can actually see it in the actual COMOS structure within the database. You have an ability to have an overview of all the documents linked to that selected asset in the same way that we've just seen on the text search for using the client. There is intelligent navigation directly to the object. And then you will also see an overview of all the engineering data. So let's have a look at the web DDMS in action. So by selecting the object search, we are able to first select the project. So this is where your actual project lives inside COMOS. The next step of this particular process is to select the site. So there could be multiple sites stored in the same database. And by putting in a small search string, such as B0, we can see that the two tanks we've just created are shown on the screen in this very nice user-friendly way. And by looking into the documents, you can see process data, you can see design information, etc., etc. So anything that's relevant to that particular tank or that object. So I think you'll see, this is the first view of the web front end, which I think is quite nice to as a user interface. Okay. What we're going to move on to now is the dashboarding functionality. So the dashboard will provide a user with a personalized entry into the DDMS, and it looks a little like a browser, which you might see on your desktop. So we'll look at some of the benefits and then move into the demonstration of the dashboard within the DDMS environment. So for the dashboarding, we allow the end users to have quick access to their data, whether they be lists or graphs or documentation. We have different dashboards for different topics and for different disciplines. And you can also create your own personalized favorites for ease of access to your data and obviously documents as well. So let's have a look at the DDMS dashboard, and we'll show you a small video of the functionality. So by accessing the dashboard, you can see here that you can create your own queries. You can see your favorite lists, access lists, documents that you need to, bit like in any sort of favorite search mechanism, you can assemble this in a way that supports what you need to do. And from the browser, you can also open the documentation, and it takes you straight to it. We can also look at creating placeholders within the DDMS structure and actually upload information, upload documentation, upload data into your actual dashboard and into the to COMOS DDMS as such. So a really powerful tool, and I think, as you can see, quite easy to use and gives you a very user-friendly experience. So the next topic we're going to come on to is the change impact support. So this function, I think, can save you a lot of time, a lot of stress, and obviously money. And why is that? Well, it's because the data that we're going to be changing is actually tracked within the system. What we're going to show you again is a few benefits of why we think this is the case, and then a brief video of how the change impact support function works in the environment. So what is the benefits of the change impact support? We have, as Tracy mentioned earlier, the need for consistency within our data. We have a consistent data flow from the asset information right through to the document content, which means that every change of data, there's also associated documents, and you don't want to do all this manually. You want that as an automated process, and so that nothing is forgotten. You also get a fast overview of the change documents, and we'll show you that in a moment, and also an impact overview of the change. So what has changed within the system. So we'll come on to the video, and the first thing we're going to look at is what happens when you change a document and the impact of that. So the first thing that we're going to do is to check out that document in the same way that any document management system would do, and COMOS DDMS is no exception. We have a good revision, a good change control mechanism within DDMS. So that what we're going to show you now is just do a small change inside this particular technical specification as it is, and then we're going to save that, and then we're going to check that document back into the system. And the next step will be to check that back in. And again, as you would have expected, a reason for why that document has been checked back into the system. We're then going to have a look at the impact of that change. So we're going to look at the details, and in the history within these blue highlighted sections, you can see that making a change to the technical specification, as by its connections and references to other documents and information and data, is highlighting in the system what other aspects of the system need to be reviewed and checked against the change that's been made in that technical specification. For example, the P&ID in this instance. So you can see the power of that change control, and what we think that this is a really simple function in COMOS, but it allows you to really remain in control of your changes, and maybe to a level that you may not have had before. Okay, so the next thing we're going to look at is the PDF content converter. This is a new addition to the DDMS portfolio of functionalities. And this converter will help us to get paper-based scans, either in a PDF or a JPEG format, into COMOS and create objects from that information. It's unidirectional and helps you to transfer data so that you don't have to start from zero by creating this stuff. You can actually get a really good starter by using this content converter function. So what are the benefits of this converter? Transferring out, the obvious one is transferring analog information into a digital world. It's taking that PDF content, taking those JPEGs and creating digital information with it. Creating real objects from those things as well, which is this is what it's all about: creating an object and having control. Ability to navigate from the object to the document, and we'll see a bit of that in the video, and of course a fast object-based search mechanism. So we're going to look at in the video how we import a PDF file into COMOS, and then show how we can navigate to those things inside the document. So the first step is to import that PDF diagram into the system, and you simply drag and drop that drawing, that PDF file into the appropriate part of the structure in COMOS, and then we'll now look at, once we've imported that, what we can then do with the information. So clearly you can go to the drawing that you've just brought in, and you can view the diagram itself. But what you can also do is type in a search criteria and type in a plant object, a device, and in this case a tank reference, and then navigate from that to the actual object inside the PDF itself. So we have just typed in a tank reference, and then by navigating to the item, you can see that there is an object created within the system, but purely from scanning in a PDF file from your paper-based records. Again, I think that's a really powerful piece of technology, and allows us to bring in data that, as we said, from nothing really. Okay. We're now going to look at the AutoCAD content converter, which is in some respects similar to the PDF version, but there is a lot more information that we're going to get within the system by bringing in the AutoCAD version. By having all these objects and their data, it really gives COMOS a different dimension when compared with other purely more document-based systems. So we'll start with the content or the benefit of the converter. So the real benefit here is being able to transfer the AutoCAD drawings directly into COMOS, creating real objects from those imported files, and bringing with them their attributes and their data, which then gives us an ability to navigate from the structure or from the object. And I'll show you a bit of that functionality in the video where we can move from one to the other. Again, a fast object-based search, and I think this is really neat, is the fact that we can put those changes back into AutoCAD from the environment that we're from the DDMS environment. So I'm just going to show you again a small video of how we can intelligently navigate around an imported file. So if we go from, again, going from this import process, we bring in our file into the structure. We can then add some basic information and what's called metadata into the system, and we basically attach that within DDMS itself. Things like the document type, the date, subject, and then we check those documents in. Check this document in. From that check-in process, you get a lot of information from that actual file, and amongst other things, you're able to view the P&ID in this case, and pan, zoom, move around that diagram as if it were, in a viewer similar to AutoCAD itself. So you can actually look around the diagram. Then we're now going to show you a little bit of the navigation, the object navigation functionality. So by driving into that P&ID, we can select a particular object, and by selecting the object, we can see in the structure the pump that you've selected and highlighted. But what you can also do is to select the object from the structure and it navigate back to the P&ID itself. Now this also works for other objects such as valves, and in this case a control valve. Again, I think a really powerful tool in which we can import these AutoCAD files and create real objects from those files. Okay, so we've been through the 7 most important data-related features, and I hope some, if not all, of those features have resonated with you and the requirements of your plants. So just to recap, we've covered functional location, text-based searching, the web-enabled search features, dashboarding, change impact support, and the 2 content converters, which are all in the data aspects of DDMS. So what are the key messages I'd like you to take away? Well, the DDMS is a perfect basis to build your digitalization foundation and can be expanded in the future. There are many options with COMOS for anybody who knows COMOS, and we think that COMOS MRO is another really good way in which this could be developed in the future. It will enable you to access the asset-based documentation across the whole life cycle, and this will apply to all the disciplines regardless of the source of the tool, and even from outside, from the web. It provides real digital data and native digital documents, and you can manage them all in one application. So this is Word documents, Excel, data sheets, etc., all managed from the one environment. It offers different import possibilities, as we've just seen, from the PDF converter, from the AutoCAD converter. Gives you different ways in which you can bring in this information. We get full change impact support on documents and asset data, and I think, as we've seen there, the power of that control is really key. And with all this, and particularly in a regulated industry, as Tracy has discussed earlier, the DDMS will make you ready for an audit at any time by giving you that real fast access and easy access to your data and your documents. So I'd like you to thank you for listening.